if you have, let's say, the nth root of x to the m, you can get rid of the radical by taking x, whatever's underneath your radical, and raising it to the m over n. So if you have the square root of 3, that's the same thing. There's understood to be a 1 here and a 2 there. That's 3 to the 1/2. All right, so if we look at your clue 1, it says the square root of a is an integer. Square root of a is an integer. Well, that doesn't tell you anything because you don't know what b is. So clue 1 doesn't work. And in clue 2, you've got the square root of b. Nope, you don't. You have b equals the square root of a. And there is an error in the solution, in the explanation to this problem. So take the cube root of ab, and let's substitute in the cube root of a. Another name for b is the square root of a. And that's the cube root of a times a is the 1/2. And there's a 1 understood there. And when you multiply like bases, you add your exponents. So that would be a to the 3/2. And you can't take the cube root of that. So that doesn't work. So the answer should be E. If you put those two together, they still don't work. The answer should be E. But they've got an algebraic error in that solution.